Good morning. So I changed the title of my talk from the title advertised. In particular, I wanted to emphasize behavior-based approach to security and actually talk about how we get there and what behavior tells us. So I think this will be interesting because I think this talk will focus more on defending, and the other talk following will focus on attacking. And I think it's a really great combination because you really need to have both sides of the story to be effective. But I'll talk about RepSheet kind of towards the end of my talk. What this really is about is that if you have a web application in public right now, it's being attacked. That's no secret, right? There's no surprise. If any of you are surprised, get ready for more surprises. It's going to happen, right? It's going to happen again and again and again, all day long, every single day. Not because you're the target of an attack, but somebody's looking for a crime of opportunity. It's a drive-by. Essentially, they're going to look for an opportunity to try to infiltrate or just exploit your system for what they can get out of it. And I want to talk about ways you might not think somebody can take advantage of your system. In order to kind of get there, I'm going to start with some very simple ideas, and then we're going to build on them as we go and create kind of a holistic approach to web defense. So I'm going to start with a drawing, and this is a pretty simple drawing. It is the default stack, right? You have some user land stuff that comes in. You have what is essentially a web server, really a reverse proxy to your application, and then your application itself. Obviously, you'll have load balancers and all kinds of other fun things in front of it, but this is the 10,000 or 50,000 foot view. And our default response to protecting our web apps is this, right? How many of you stop there? It's okay to raise your hand. Yeah, sure. I mean, the reasonable approach is we protect this by putting a login in front of it. We have a username and a password. And there's lots of ways to manage that incorrectly. But we'll focus on that for just a minute. And hopefully you have a better designer than this. So what happens, right? You come in with a username and password. And you provide that via a request. The request comes in. It validates whether or not the request was good or bad. And then we go on with our day, right? And that's where the security stops. Really, actually seriously consider this. When you're thinking about security of your applications, how many of you actually do stop there? Where's the additional controls at? How many of you ask a second question later on? Maybe somebody logs in and they come back. How do you verify that they're the same person, that their session wasn't hijacked? How do you validate that if you're over SSL, their SSL session wasn't hijacked? Which is a much more interesting topic that we're not going to get into in this talk. But it's really about asking more questions. There's a lot of data that comes in, and we ignore most of it. Data that helps us decide whether or not something is actually good or bad. And getting back to behavior, it's not the behavior that I'm after, it's the intent. And the way to get there is to derive the intent through the behavior. But I want to make kind of a caveat here. And this is a really important point. And I think this is wrong in security over and over and over again, is that I don't want to ever impact user experience. In fact, I want to make it better. Right? There's this weird little balance where security and usability seem to be kind of on the opposing forces, right? They kind of butt heads. I think that's terrible, right? I think one of my favorite models for security is a casino. How many of you have ever seen the security in a casino? Really seen the security, right? You don't actually see the security in a casino. You see some shows, some show of authority or some show of attention that makes you think it's not feasible to steal from a casino. What's going on behind the scenes is just monumentally complicated and really, really intelligent and sophisticated. And that model, I think, is interesting because you're there to enjoy yourself. And they allow you to enjoy yourself and do whatever you want. And then when you're suspicious, they act on you. And I think that's a really, really interesting idea. So that's different, right? That's a different approach than kind of the standard textbook approach to security. So I want to talk about the kind of ideas that get us there and then some pieces on maybe how we can change the game for ourselves. I'm going to start with signature-based detection. There'll be some pretty simple ideas. The ideas that I think are really important here is anomalies. How do we define anomalies, and how do we figure out what they're worth, right? Whether they are showing intent of malicious behavior or just somebody being confused, or maybe even a bot that's harmless. I want to talk about reputation management, and that's where we're going to start to collect, store, and kind of propagate information about what we learn about activity of actors on our sites. And then really how to act on them. Like, what do you do when you find out somebody's being malicious? There's lots of different things to do than just stop them from coming in. There's actually some really interesting ideas there. And then finally, a tool that I've created to kind of help manage this whole infrastructure called RepSheet. It's an open source project, and I'll talk about kind of where it fits in and why I kind of got motivated to start building those tools. So we'll start with signatures. And this is going to be the kind of the easy part of this conversation because it's very straightforward. Just to get a kind of idea of where we're at, how many of you have not heard of mod security before? OK, cool. So many hands. Great. Mod security is something we call a web application firewall, or layer 7 firewall. It's an open source project. It's rule-based. So you give it a bunch of rules, and it will, and what they really are is a bunch of really nasty, long, regular expressions that match patterns on data. It's an interesting project, an interesting idea. I'll talk about kind of some of the downfalls of it as well. But the kind of basic idea is it allows you to block traffic or kind of alert when it sees an attack. Let's say you have a form and somebody puts script, alert, script, and script and posts it. Mod security will see that and go, that's a cross-site scripting attack. I'm going to stop that. I'm going to let you know that that was an attack. I mean, obviously, it gets much more sophisticated than that, but that's the basic idea. Mod security by itself is a framework. It's kind of bare, and then it has this kind of core rule set. And the OWASP project kind of provides this core rule set along with mod security. And it's all covering the OWASP top 10 and some of the kind of basic attacks you'll see, along with some of the more advanced attacks too. And honestly, it's a really great tool to add to your stack because it provides data. It works well in most modern web servers, so Apache, Nginx, IIS. It was really designed to work with Apache, works well with Apache. The other two web servers are, it's interesting. So if you're in Apache, this is a very simple install. If you're in Nginx or IIS, it's a little bit different, but it still does work. But it requires lots of tuning. The problem with rule-based detection is that tuning is super important because the way your site operates, the way people interact with your site, the way you've written your code to interact with your servers, it all can trip these rules, right? And so there has a high possibility of false positives. So that's not good, right? False positives are really terrible, especially when you start to block traffic. And so you can kind of operate mod security in a couple different ways as the passive and active versions. I tend to operate in the passive version by default because I actually don't want to block the traffic on just a rule match. I want to be a little bit more intelligent about what I'm doing. But there's a class of attacks that this is really good with, and that's the zero-day attacks. How many of you remember the Ruby on Rails remote code exploit from few months back, right? So after this was published, very recently, or maybe within a few hours, mod security rules were also published to block this attack because the signature was very simple to detect. So folks that had a long patch cycle or couldn't quite get the release out the window, when you know there's this giant gaping hole in your Rails application, were able to install this rule in mod security if they had it running and stop the attack while they patched their server. So it will buy you some time while you're fixing your software. For instances like that, I think it's actually incredibly useful. That's kind of effective in just isolated situations, not day-to-day. Day-to-day, what I'm really looking for is the data. Right? Did something smell weird here with this request? Right? Normally, I wouldn't see these kind of things. But what mod security will tell you is this request was unique. It was different. Something's wrong. I wanted to investigate further. And that's, I think, the power here. So we update our model. And what changes is we add mod security to our stack, right? It's still kind of inside the web server. It's a module you load into your web server. With Apache, it's a dynamic object. With Nginx, it's compiled in. With IIS, it's just a DLL. It gets loaded. And we kind of go on with our day. There's not much to really consider in the world of static firewall rules. It's pretty simple. Where we want to focus more is on anomalies. So I want to stop for a minute. I'm going to show you a series of requests, 4 requests. And I want you to try to figure out what's going on. And this is what I mean by kind of deriving intent when I'm talking about it. So the first request, we see a post to /login here. And then we see other information about the request. We have a user agent. We have an IP address, size of a request. That's the internal IP. Nothing in particular, but this is the first request this machine ever made. Now I'm going to show you the next 3 requests. So here's the next one. It's a post to users, username, and credit cards. This in particular is another user agent, IP address, etc. The next request. And finally, the last request. What's going on here? Trying to look for buffer overflow. Why? There's something much, much more obvious happening. I'll replay them one more time just to get us in the right place. So, post a login, request number 2, number 3, and number 4. So, what do you see here? Sorry? Yeah, the request rate is 1 second in between intervals. The first request was a post request to a form. What should precede a post request to a form? A GET request, right? You should get the form before you post it. There's some other things too. Let's actually take a look, right? I see a website getting carded. So the industry that I work in is credit cards, right? Braintree processes credit card information. In particular, there's an event if you take credit cards called carding, which raises the question of what in the world is carding. How many of you take credit cards on your websites? All of you are being carded. I can pretty much guarantee that. If you take credit cards on the internet, you're going to be the victim of carding. What this means is that in order to provide good service to your customers, you're validating their credit card when they enter it. So you have a profile page, and on that profile page you enter a credit card number. And what happens is that credit card is verified as valid before you then try to purchase with it. That way the purchase experience or checkout experience is good, right? You don't have to worry about this weird little situation where they're trying to check out and your credit card information isn't right, so they can't make the sale, and then they just go away, right? And you lose a sale that way. So you try to kind of preload this negotiation with the credit card company and make sure the credit card is good. And so what you're doing now is offering a free service to anybody who wants to validate stolen credit cards. And this is very mechanical. There are very large criminal organizations that this is all they do. They steal credit card numbers, they generate credit card numbers. The space of valid credit card numbers is very small. It's 13 to 19-digit numbers. There's an algorithm called LUN10 that validates credit card numbers. The space of LUN10 valid credit card numbers is very small. You can just generate them. There are known quantities of information about that credit card number. The first 4 is a back identifier. There's a BIN number. That's a bank identifier. There's lots of different things that show you exactly who is backing this card and what type of card it is. The actual unique numbers are even smaller part of that. So the amount of stuff you have to generate to just test whether or not a card exists is really tiny. And a lot of us will give you that information back and forth. It's like, oh yeah, the card's valid, but the address is wrong. And so they'll just keep going until they try to figure out valid cards. And then they'll go on and on. And they sell these in the black market for actually lots of money. And the way they do this to test is they hijack servers. They have scripts that run around the internet, just basically taking control of machines, putting them in charge of a command and control network, and then distributing scripts for each one of your sites to go and test stolen credit cards. Hundreds of thousands of servers, they're for lease. Essentially, what they end up doing is it's EC2 for bad stuff. You can rent time on these servers that are hacked to do whatever you want, right? And what's interesting about that is they're doing it a lot. I worked at a company where we saw upwards of maybe almost 1 million a month requests of trying to validate credit cards. Now, what they'll do is they're smart. They'll fly under the radar, based on how big you are, how much traffic you do. They'll try to not be too aggressive, but their scripts fail from time to time. So enough aside, that's the idea of carding. The play-by-play, the things that are interesting about this request, right, and this is what I said we ignore the data a lot, are a couple of things, right? The first thing I already pointed out, there's no GET request before the post happened. Something is wrong here. Now, maybe their IP flipped in between they were making requests. I don't know, right? It's not enough to say that's bad. It's just different. Also, there's a 1 second delay in between every request. I don't know about you guys, but I cannot type my credit card information in in 1 second and hit enter, and then do it again in 1 second and hit enter, I know my number in my head, but I still can't type it that fast, and all my other information. So something else is different here, right? The request rate is just too uniform. Third, how many of you remember when Windows 7 was released and what version of Firefox was out when Windows 7 was released? So let's say you install Firefox the very first day Windows 7 was released. What version of Firefox did you get? Yeah, not 8, right? Maybe 3, because Firefox has some weird versions, but it was definitely not 8, right? 8 was already out. So this is an older version of Firefox. Something doesn't match up here, but more importantly, Firefox 7 and Firefox 8 are associated with what very common tool as user agents? What headless tool? Selenium, web drivers, right? This is a very common user agent to have on web drivers from Selenium, et cetera. So if you're doing headless testing, you'll see this user agent quite a bit as well. Also, Windows NT 6.1 will tell you the version of Windows. The revision number or service pack will tell you kind of what patch level of Windows they're running. So a lot of times you'll see MSIE 6, NT 5.1, SV1. That's saying that this is Windows XP Service Pack 1, running IE6. That's usually a lie. Most people running XP are at least patched beyond that. So user agents can be spoofed, not really a big deal, but something to consider, right? Things are starting to add up, right? Things are becoming more and more suspicious. And finally, I'm going to tell you that this was a US company doing US-based business. So the last thing here is that the request came from Bulgaria. So now we have 4 things in 4 requests that all don't add up, right? You can see the story is a lot more compelling now than it was that first time when I had this post without a get, right? It's interesting, but it's not offensive in any way. But now we see this is building a story. We're building a tale. And we can be pretty sure here that something is bad enough we might want to take action against it. Now, the other thing is that this continues 10,000 more times. So we're pretty sure it's a carding attack. But the thing is, we don't want to wait 10,000 times before we do this. Because you can make 10,000 requests pretty quickly. What we really want to do is do this in 4 requests or less, right? I mean, obviously, there's other ways to deal with this, but we want to do this as fast as possible to prevent those carding attacks. Because if all we have is blocking the IP, it's like playing whack-a-mole. And it's worse because you have to play like multi-threaded whack-a-mole. Because they're coming at you with tons of servers. As soon as you block them, 5 more pop up because they realize you took action against them. So the first thing they'll do is just hit you with 1 server until you stop them. And then they'll get more aggressive. The strategy changes. These bots are actually really sophisticated. As soon as you change, they change too. And this game is of cat and mouse. Just goes back and forth. So you want it to be really easy to detect, really easy to block, and kind of automate itself. So I'll tell you that for that particular IP address, it was the only request that ever made, and it never appeared again. Just disappeared forever, right? This is part of these attacks, right? They're fraud attacks, but at the same time, they cost you money, right? There's operational costs, but all of those transactions back to validate credit cards cost you money, right? Some services don't charge for that, some do. It depends on your deal. But at the end of the day, in most cases, it actually costs you money. So at the very least, they're costing you, I mean, maybe pennies, but millions of pennies add up over time. So there's something else that gives it away. Now, this is kind of playing into more of the anomaly side of the world. There's something that's very simple about the nature of what happened in these requests. It's very, very obvious, but we tend to ignore it. Anybody think about what else might have given us away? Think back to that first comment I made. So what was in common across all 4 of those requests? So that we had IP, we had user agent. What else did we have in common? All 4 of those requests were what type of requests? Post requests. Yeah, we never had any gets that followed the 302, right? So there was that 302 that was responded on that was never followed, right? That's another huge indicator. But we've seen an anomaly. I can guarantee that. Because how many of you have websites where the distribution of HTTP verbs is post 100%? Actually, at Braintree, we have one that's almost that way. Our gateway API is almost all post requests. We have puts and deletes as well, but it's legitimately almost always posts. But that's not common, right? Most of the time, you have a distribution of traffic that looks something like, well, maybe not like this. I made up a bunch of numbers, and I think they add up to 100%, but you get the idea, right? There's a distribution of requests. And if you sample your traffic at any point in time, you can calculate this distribution. And then you can take a single actor and calculate their distribution. And there's this wonderful thing called statistical significance, right? Have they deviated? Is this different enough to be an anomaly? It's really simple, but it's incredibly powerful. Because when you design an interaction on your website, you intend people to follow your design. User experience is about leading somebody down a path. And if you've created a path that everybody follows, the distribution on requests is going to be the same for everybody else. And when it's not, there's intent there. Something is wrong, right? Maybe it's a confused user. Maybe they don't know what's going on. Maybe they're a Luddite that just used a computer for the very first time and don't know how to click on things, right? There's lots of different things. Maybe you made a mistake. Maybe you had A/B testing that went wrong. There's lots of things that could have happened, but the interesting part here is that there's an anomaly. And that is the first part to figuring out that maybe you want to take a closer look. So this distribution of HTTP methods, super easy to do, and actually becomes really important. So getting back to behavior, right? When somebody deviates from the standard pattern, the standard actions, there has to be a reason. We want to find that reason. That's kind of driving me towards my point here. Let's kind of take a tangent for a minute, though, about behavior, and I'm going to talk about GeoIP. Because remember I talked about Bulgaria being the request and having be a US-based business. I'm going to talk about a behavior change that's actually probably affected some of you in this room. And GeoIP can help you. It's a really simple idea to add, right? Mod security was a simple plug-in. GeoIP is also a simple plug-in. This is just look at data, act. So it's generically useful to have GeoIP data. If you want to know where your traffic's coming from, and maybe you're looking to expand your business and you want to add locales, more languages, maybe you look in GeoIP and say, where's everybody coming from? I'm going to go to that language next, right? It's easy to have some business intelligence, but in the face of an attack, it actually helps as well. It helps you protect your users. That might not be obvious how yet, but I'll paint a scenario for you. Remember very early, I had King Roland logging in. Let's say King Roland gets his Gmail account hacked. This is a pretty common thing. What is the first thing somebody does when they hack your Gmail account? If they're really going after information, what are they going to do? Any guesses? They might change your password, and that's cool. What else are they going to do? Yes, absolutely. So how many of you use your email address for every social network, everything you buy with? I mean, you have a digital footprint. It's enormous, right? It's all linked back to that one email account. Maybe a couple of email accounts if you're, tricky about how you do things. But generally, it's tied to one email account. They're going to go, and they're going to try to basically steal stuff from you. That's really what they're trying to do when they hack your Gmail in most cases, is steal stuff, right? Buy stuff on websites under your information because your credit card's there, you're already authenticated. But the magic thing, how do they hijack the account? What do? They say, I forgot my password, right? And they send a password reset request back. We're really nice. We want to have good customer experience, so when you forget your password, we want to send you your password. Or maybe not your password. You shouldn't do that. You send the password reset request link. And they click on that and they change their password. But now that they own your email account, they just click the link and type in your email address, and now they can take over your account. It's really easy, right? This is super simple. This is effectively how we deal with forgotten passwords, right? But there's a loophole, because once they own your email account, that's kind of game over for you. So they send the password reset request. Normally we respond with the password reset, because that's what we do. We want to be, we want our customers to use our sites. So maybe you don't, right? Maybe you don't quite just send the password reset request. Maybe you keep track of the GeoIP region that person always logs in from, or maybe the last 10 requests. So we can know from history that King Roland always logs in from Druidia. That's going to be true across the board. But all of a sudden, for the very first time ever, we see a request for this password reset coming from Spaceball City, right? It's never happened before, but it happened just now. And it's not like it's a login attempt, which would be interesting, or even just a simple attempt to access our website. It's this particular password reset request, account modification request, coming from a previously unknown GeoIP region. Something is wrong here, right? This is that anomaly thing. This is a behavior thing. Something is wrong. So instead of sending the reset, you ask questions. And this is where security controls and usability actually start to, the line blurs, right? Because you can change the experience. Now, instead of sending the password reset request, maybe they have to answer some questions before you let them reset their password, right? Normally you say password reset request, you hit the link, you change the password, you go on. That experience is fine for everybody who seems like a normal user. When they're not, you change your controls, you dial it up. You make it harder. Or maybe you don't send it at all. Maybe you say, please contact customer service, and you have a script that you run through with them and you ask them questions. There's plenty of ways to approach this, but the point is that you stop. And the end result is hopefully you protect that user from bad actions, from having everything else compromised. And you owe it to your customers to do that, right? If you are holding their credit card and charging it, you have a responsibility to them to protect those assets. Because if their Gmail account gets hacked and somebody buys stuff on your website through their accounts, guess who's at fault? It's not Gmail. It's your crappy security that made this happen, right? People react to this. It's not rational. They don't realize that they got hacked, they got the Gmail hacked, and then they logged into your account, and they hacked your account, and then got the password, or not the password, but the credit card and charged something, right? The problem is your site charged them money when it shouldn't have. So it's your fault. And that's powerful, something you have to remember, because you do have a responsibility. So, I mean, there's also the kind of big, large brush kind of approach where you could say, well, I only do business in these 3 countries. So any other requests from any other countries, just turn them off. I don't care about them, right? That actually is a whole class of problems that disappears. Now, it creates a other class of problems if somebody's traveling to one of those other countries, then they can't use your site. So you want to be careful about this, but maybe there's a country in particular where you just never do business at that is always bothering you. You can just kind of like turn them off. You have to hit the knob and say, you just go away, right? And sure, they could come from a different IP, from a different place. There's Tor, there's lots of things, but 80% solution works really well most of the time. It definitely helps out. And so you just kind of turn the volume off for certain countries. And so now our model looks different, right? We've changed it one more time, but we're still in the web server space. The GeoIP stuff is modules. Every major web server has a module for GeoIP. There's stuff you can do in code as well, but it's slower. The database is actually the same for all of them. Pushing it up to the web server level is actually nice, because now it's in the headers of the request. It's done really fast, usually done in C or something quick, and the headers come down. You can just access them and use them. That's what you're after in the first place. So some other anomalies that exist. I don't want to go into too much detail about all of them. We won't have enough time. Request rate is really simple. How fast are they making requests? A normal user makes requests at, a human user, right? Every 30 seconds, a minute, 2 minutes, something like that, right? Sometimes you have mechanical interfaces that are different, but it's important to kind of understand what that is. Really, really interesting. There's a thing called header order, right? What are the order the headers are sent down to your server in? You never look at that. It's just data. It's noise, right? You might look at the headers themselves, but they tell you something. Every browser has a unique header order. It's a fingerprint of that browser. If somebody says, I'm MSIE 6 on NT51 Service Pack 1, there's a header order. And you can look at that. And then you can decide, did the headers come in that same order or not? Because if not, they're not MSIE 6 XP Service Pack 1. Something is wrong here. It's a really easy thing to follow, but it's also a clue. And so maybe this is not who they say they are. Maybe there's an imposter here. And if somebody's impersonating themselves or being an imposter, they probably don't have good intent. Now, maybe they're running an add-on that's just doing something like that to, maybe they're really conscious about privacy and they're trying to do something different. I don't know, right? But what it says is there's an anomaly here. Something is wrong. Something is not what it says it is. TCP fingerprinting, passive TCP fingerprinting. When they pass you packets, you can sometimes, not with a super high degree of accuracy, but in a lot of cases, detect what the OS is that's coming in. You match that up with the user agent, and if they lie, then now you have another point of data. So it could say the header order is off, TCP fingerprint is lying. It's basically building a case. You're building a story on whether or not you want to act on somebody. If you have users, if there's a high volume of account activity, creating, deleting, subscribing, unsubscribing from a single actor, something is maybe wrong. Maybe there's lots of users being accessed from a single IP address. Something's fishy, something's wrong here. Really, like, your business is unique. You're a snowflake. Anything can happen. You have to build the case around how your business functions and decide what's good and what's bad. This is an open-ended story, but there's a common place here, or a common theme, I should say. And that's, does the behavior fit an equation? Can I actually say this greater than this is bad? Something along those lines. You can basically look at data, apply a formula, and get an answer. That's step one, right? Your detection is super simple if that's the case. So examples of this are things like, is the request rate greater than the threshold? Does the TCP fingerprint not match the user agent? Header order, same thing. But that whole thing about deviation of HTTP verbs is actually a little bit trickier. I could say it's deviated, but that doesn't mean that it's got malintent. For example, the Googlebot. We love the Googlebot. It makes us popular in search engines, or Bing, Yahoo, whatever, right? We want that to succeed. We don't want to block that. But it's different. Its behavior is not the same as everybody else's. It's basically a bunch of GET requests. But you can look at the user agent. It says Googlebot. You can look at the header order of the Googlebot, which is very important, and make sure it matches. Those kind of things are important in the request as well, but you want to make sure that you're not blocking things that are actually, they're deviated but for a good reason, right? They're anomalies with good intent. 100% post requests usually is a sign of bad behavior. But like, it's not always that simple, right? There's gray areas in how you would judge good or bad, or intent in general, right? Next scenario, right? You have a high request rate, people signing up for your service. It's all coming from a single IP address. Is that good or bad? Yeah, so now you have to decide whether it's an added IP or whether or not it's a fraud, it's spam, whatever, a bot of some kind. It could be that you just ran a deal and everybody came into the office and there's an office email to everybody saying, hey, this company's selling out something for half off. Go sign up and buy it right now. And everybody at the office at once just goes and signs up and buys something. That's actually good. You want that traffic. You don't want to dock it or deny it. On the other side, this gets harder. So there are things you can do to determine whether or not there's possible fraud or possible bot activity or basically mechanical activity. Obviously, that request rate thing, all the stuff I talked about is there. But there's other formulas. How many of you are familiar with the Levenstein distance function? What's it really, really good at? If you give it an email address or two email addresses, it's going to tell you how different they are. So the user is going to sign up with an email address. I'm assuming your site has users, so if it doesn't, then this doesn't actually apply. There are other ways, of course, but this scenario is you have users have emails. If this is legitimate activity, you're going to see the emails be very different, right? They may all be at, companydomain.com, and that's fine, but that first part matters, right? If it's, John Smith at company.com and Irene Sanders at company.com and, multiple different names, the distance function, the score on that function is going to be high. These emails there's nothing in common with them, right? But now the other scenario is we have Joe Smith +1 at gmail.com, Joe Smith +2 at gmail.com, Joe Smith +3 at gmail.com. The distance function, the score on that is very low. And so now you have this other metric you can use to kind of score activity and decide whether or not it's mechanical in nature. Super simple trick, works really, really well. Also, if they come from hotmail.com, you just deny them because they're probably fraud. Joke, not all Hotmail is bad, but the majority that I see of spam accounts created link back to Hotmail accounts. But it's usually some big, long nonsense gibberish at hotmail.com, undecidable, generated almost like a UUID. But I actually do, when I see emails from Hotmail, they actually are flagged automatically. Not that they're automatically bad, because I don't want to suggest that. It's that they tend to have a higher risk associated with them, because there's more fraudulent activity associated with Hotmail. So it's just something to consider, right? It's data, and this is all about data. That's what this really is, and I'll get to that in a minute, right? We have these patterns and we have this data, but we can't fit it to an equation. So what's the next step here? We have a formula we haven't quite fitted yet. We can't apply any meaningful thing. What do we do with it? What's our next logical step? So it's time for quantitative analysis, right? we have data, we have a pattern. One of the things here is you can use this to use statistics to try to fit a pattern. But I really can't call it quantitative analysis because that's not going to get me $100 million in VC. So I'm going to call it security as a data science problem. What this really is that I'm going to turn around and apply some machine learning and basically try to classify data. I'm starting to develop all these routines for collecting points of interest or information. If I can't decide whether or not it's good or bad by just looking at it, which is tough because there's a lot of traffic, maybe I can find a way to classify it and tag it. Scoring is good, scoring helps, but like maybe I want to classify the traffic right up front using some different mechanisms. This is interesting, and we're going to talk about this more in a little bit. But I want to update our model again now that we're kind of interesting. We're changing some stuff, right? So there's a problem that immediately exists when we add a classification mechanism, and that's that they're slow. Some of them are fast, but in general, the things we're going to run are slow. And everything I've talked about so far has been inline in the request in the web server. I can't put my classifier here and expect it not to impact performance in a significant way. So it's going to have to go off to the side. I'm not sure where yet, but it's going to have to go off to the side. So just a side note is that we've taken a detour on throwing everything in the web server and making it work. But I do want to tell you that there's a lot of value from this. So we're going to throw that problem on the side for a minute and come back to it. Because we can combine the signature detection that we did earlier and some of the points of data, and then start to kind of really churn on it and figure out whether or not things are good or bad. And over many web servers, because most of us have more than one web server, we want to have to collect some state and maybe see all the requests that a single actor made across all of our environments and maybe make some choices. Right? It's about state. We have to keep track of all this. That's how we manage this across environments. And that's where the idea of reputation comes in. It's intelligence that we provide based on how somebody's acted on our site. And across all of our environment, we might have more than one app. We certainly have more than one web server. We probably have more than one application as well. We run this across everything and put it all back to one centrally stored state. And then that's how we derive this reputation. And really, it's like who's bad and who's really bad. We're trying to figure out. It's our naughty list. It's who are the list of people who are currently just misbehaving. And it's built up from the tools and techniques and models that I've been talking about all along. But it provides one solution. It's local reputation, right? It's only reputation based on how they've acted against you. But this is not a new idea. This has actually been around for quite a while. There are companies who have honeypots all over the internet, and they actually sell feeds. Like you can actually purchase these external reputation feeds, and you can merge them together. So let's say you flag somebody, and then you also find them in that external feed list as being malicious. So it's really easy to say, oh yeah, they're definitely bad, right? They match, they hit here, I had some suspicion, they match on this list too, let's just block them. So this is important, and they're actually pretty cheap. Some of them are free. I think the company Alien Vault has a free one they publish. And it gives you a really good idea of kind of what's happening in the rest of the world. It's kind of a temperature. And this combination gives you this really solid awareness of kind of who's doing what, who to keep an eye on. But we've actually caused a bigger problem. So now we have this whole idea of reputational intelligence, or state. We also have these external feeds. And we're starting to build this thing. These are all detached from our web server. So now we're building ourselves into this kind of weird little corner where things don't quite match. We don't know what to do. But I don't want to solve that problem quite yet because I want to introduce one more problem before we solve it. And that's how we act. When we decide somebody's bad, we want to know what to do with them. There's a lot of things you can do. We have all this new information. Actually, it's not new at all. We actually had it all along. We just never looked at it. It's new to us, right? We're looking at it now. We're trying to figure out what to do. Now I want to know what to do with the information once we have it. Once we've decided, yes, this person is bad, I want to act on them. There are many things you can do, and it's not always obvious which one is right. Here are a few examples. We can block the traffic. That's the obvious one. We can honeypot the traffic. This is interesting, and I'll talk about that in a minute. We can modify our response back to them. Maybe we change our controls. Maybe we change what we respond with to them because we're not sure whether they're good or bad yet, and we're trying to figure it out. Maybe you attack back. I'm not going to talk about that one. There's some gray area there. And if it's really bad, maybe you just contact the authorities. Maybe you need to actually call in somebody to help you out. Maybe it's really bad. It's affecting your business. It's a big deal. Be careful of that one. That one actually has a lot of implications. Realize when you make a request to the authorities, they're going to ask you lots of questions back, and be prepared to spend a lot of time answering questions. And not always in questions you hope they would ask, right? So it's very much an opening of the kimono. They're going to give them a lot of information. It's going to be very taxing. So reserve that last one for when you actually need it. Sometimes it's necessary, but be prepared for what happens when the time comes. So blocking the traffic, super straightforward. In most cases, when you're talking about the web server, you're returning a 403 response. You're saying, no, I'm sorry, that request is forbidden. You can't have it. The other obvious thing is you're going to block at the firewall level. This is trickier because some of you have upstream providers. How many of you have like an Akamai or a Prolexic or a Cloudflare or some kind of upstream provider that's a CDN, termination of SSL, et cetera? What they're doing is actually sending you down not the actual request. They're going to terminate the request and make a new request back based on the information that was given to them. Now that request is coming from an IP of the upstream provider, not from the other one. Then you get this thing called X-forwarded for. The headers comes in there, and you have to kind of determine. Now your firewall has to do this extra packet inspection and pulling out that header and blocking the traffic, and it gets kind of weird. So there's advantages and disadvantages to both of them, right? You have to be careful on how you work, and it's really about your infrastructure and how you operate your business. That's where you decide where to block. And maybe both, but honeypots are actually way more interesting than this. There's a really cool story here. You can take your environment and you can modify it. So in this case, when you see that box as engine, imagine that's this whole thing I've just talked to you about, this whole reputation and action model. It's going to sit in front of your kind of frontline load balancer, and it's going to decide whether the traffic's good or bad. And if it's good, you get routed off to the normal place, right? Your standard site, they interact. If it's bad, they get routed to the fake site. What the fake site is just another instance of your site with all the production data replicated over, but the back end disconnected. No charging money, no shipping goods, no actual action. But what you're doing is allowing them to just keep doing what they're doing, and you can study them, right? When you honeypot an attacker, the goal is they don't know they've been caught. So they're just going to keep doing what they're doing, and they're going to exhibit all the behavior that they would have had they successfully attacked your site, or if they were trying to attack, what they would have done to attack. And what it does is allow you to study their behavior. It allows you to figure out what they're trying to do. And when you see that, then maybe you start updating your approach, right? Maybe they actually get in, but it's a fake site and it's fine. You update your approach on how you prevent attacks. Or maybe your understanding of what people are really after. Because it will help you, because you see the signal to noise level is super awesome in that case. Like you see all the signal because it's a raw attack. But at the end of the day, we can't get away from this whole out-of-band state management weird little problem that we've come into. Is we have this nice little solution in the web environment, and then it detaches, and now everything gets really weird, right? We have to figure out where do we do the acting at? Where do we hold the state? If we wait till the application environment before we act, or have we waited too long? There's lots of questions to answer here, and this is kind of where I was at. When I started to solve these problems, I saw this pattern. This pattern kept coming up over and over again of how do we do this other weird out-of-band stuff? And that's what brings me to RepSheet. And this is why I made it. It's essentially a reputation engine. That's all it is. It changes the model a little bit. What happens is it's a module for the web server. It's also a backend environment, and it uses Redis as an ephemeral cache. Basically, it doesn't matter storage. What it does is a few things. It reads and writes back from Redis, but what it does is it records activity. So every time requests come in, it records certain pieces about that activity, timestamp, user agent, method, query string, simple stuff. What it also does is manage that state for you. And that state can be available to all your web servers. So you have this nice globally managed state that all your web servers can access. You also have something that will act. What RepSheet really is at the very, very core, the very basic primal functionality is it looks up in Redis to find out whether or not you flag somebody, and if it does, it will either block them or notify. It's a really simple model. And finally, you have that out-of-band processing. It's that backend that will churn, run the models, and then it will update Redis when it figures out that somebody's been bad. So it's that out-of-band updating when it sees aggregate data across everything. And it also will integrate the external feeds. So the other piece here is visualization. Really what I built this for was to understand what was going on. I want to know what's happening. I've built a very small visualization tool. I suck at UI, so it's just a little Twitter bootstrap thing. But it's super helpful, because it lets me know what's been blacklisted, and the top 10 offenders, right, the people who are currently suspects that haven't been blacklisted yet, automatically or manually, right? You see the buttons that automatically let you do it. What you see is a bunch of information. It might be hard to read on this screen, but all these here, in this case, are mod security rules that that person has triggered. They've tripped all of those mod security rules. And they've done it 23,567 times. They're probably not good, right? This one's a really obvious case of an offender. Somebody, in this case, right, they were just running a scanner against our site. Akinetics, NetSparker, one of those tools, those free tools that you just scan sites. The other thing is humans are really good at patterns and recognizing patterns. So I added a visualization of the world in pins on a map. Let's say, here's where your threats are coming from. The interesting part is this is 24 hours, average 24 hours at Braintree. There's a lot of pins. We're a big target. We move money. Our latest numbers are about $12 billion in transactions a year. It's a lot of money flowing through us. People want to steal it. Seeing this is interesting. Seeing all this noise doesn't help much. So, it gets better as time goes on and you start to identify and block legitimate traffic. But it has helped us spot botnets in the making. We saw a botnet pop up in France that started with small and got bigger and bigger. It was isolated to France, though. We saw it more and more every day would grow and grow and grow and grow. And we saw it hit critical mass. But we saw the details the whole time. We knew what the user agent was. It was a very simple botnet. But when it actually turned on the fire hose, we knew what to do. It was really simple. We called up our upstream provider and said, hey, this user agent, just block it. It was over in 5 minutes. So what would have been a pretty catastrophic denial of service attack, which would have probably hit us, I think they tried to hit us with about 10 gigs, which is not huge, but still a pretty significant amount of data. It would have been disruptive. It would have taken a while to figure it out. We already knew it was coming. We already had the alerts on. So once it happened, it was a 5-minute deal and it was over. So it helped. Those patterns are really, really useful. So what RepSheet really does is put everything together. Like I said, the web server model records the activity and it looks for offenders in the cache. The overhead of this is anywhere between 5 and 10 milliseconds or less, depending on how local Redis is, really. That's the key. So it doesn't really impact performance to eyeball time, right? 10 milliseconds is still a long time, but to HTTP, which is slow in general, and humans which are perceiving that data, it's nominal. It listens to mod security, right? So what it does is it listens to the information mod security is sending down in the headers and picks it up and records it. So if somebody trips that, it's going to say, hey, mod security, I found out you alerted me. Here are the rules they triggered. And it will keep count. And then it provides that idea whether you can block or notify. So it's going to help you build that case. In this particular example, blocking happens at the web server level, right? The RepSheet module will block inside the web server. And that's the 403 instead of the actual firewall. But since that Redis database is open, you can actually write a small script. There are plenty of tools like IPset that help you update IP tables on the fly. You can write a little script that just looks in Redis at the people you blacklisted and updates your firewall to block them. Really easy, couple-line script. The difference is notification versus blocking. So notification sends the headers downstream. It actually adds an additional header, XRepSheet, and says this person is on the RepSheet. So the application that's downstream can say, I'm going to change my behavior. They've been flagged as bad. I'm going to act differently, which gives you the power to choose how you're going to respond. For instance, show CAPTCHA, right? This is simple, but CAPTCHAs suck. We all hate them. They're terrible. And when you're a legitimate user, it's a pain. And this is that whole cross-section of usability and security, right? So I say turn it off until you know that they're acting bad. Then turn it back on again. Make it better. Make a better experience for people who are legitimate, and turn it on for the people who are bad. The backend looks at the recorded data for bad behavior, and then starts to make a case. And when it figures out something's legitimate, it updates the cache, and then you benefit from that. The good part is this is a plug-and-play model. It's a sorting hat without a brain. You give it the brain. You hook it up to Splunk, Logstash, and those other things, and produce that data. It's a project with a bunch of repositories, the visualizer, the module, everything's kind of in its own place for logical reasons. GitHub.com/RepSheet is the organization. So summary is simple. There are lots of indicators of attack. They're everywhere. And the data isn't data you have to fabricate. It's in every request. It's a matter of how you look at it. You want to build up a system that can capture the data and sort the good from the bad. Understanding what's going on is like critical importance to being able to protect yourself from attacks. The tools we covered are mod security, GeoIP, generically, the custom rules, the way your business works, behavioral classification, and finally RepSheet. The one thing to remember, though, is that baselines are important, and they're getting attacked every day. At some point, your bar and the other bar are going to be in contest with each other. Right? If your bar is too low, the scripts are too high, they're going to get you. So this is step 2. Step 1 is do all the things you're going to hear about in the next talk. Look at the AWS top 10, defend your code, make sure it's solid, make sure your defense in your code is just as good as your defense in the perimeter. And I think I'm just about out of time, so if we're going to do questions, we'll have to. All right, one quick question. Interesting question here is, why lie about which browser is being used? This is interesting, and there have been a lot of reasons, a lot of things that have come up around this. For instance, there was a travel site at one point who, if you came from a Macintosh computer, the rates you got were higher than the rates for a Windows computer. Don't know why, but it was categorically true. You could change your user agent, and you got lower prices. So that's one reason to lie, right? Some sites say, well, I only work with these browsers. So you go, okay, fine, I'm this browser. Stop blocking me and let me go through, right? Another reason, right? So actually, there's legitimate reasons why you would change your user agent. Most of the time, when the user agent is lying, it's bad. But remember that it's not always bad. So there's kind of some gray area there. Time for one more? What's the bridge between mod security and RepSheet? The bridge is very simple. Mod security has an option to enable headers. So what it does when it sees an attack come through is it adds headers to the request that says, here are the things I found. Here are the rules that triggered. All RepSheet does is look at those headers because they're in the environment in Apache or in the web server module, and pulls them out, parses them really quickly, and then puts them inside the application. So if you have mod security turned on, RepSheet benefits from that by just parsing the data from mod security in the headers. That's all it is. It's very simple. Otherwise, I'm out of questions or out of time. Thank you very much.